Very good morning to everybody. Myself, Dr. Kalyan Gayan. This semester, I am the instructor of your mass transfer course. And if you see, instead of writing mass transfer, I have written here mass transfer 1. So, because this is a very core course, very fundamental course, as a chemical engineer, the course is very important. Not only in your chemical engineering discipline, and if you see the gate questions, around 15 marks will be from this course, 15 to 20 marks. So this course is very important, and that's why we have divided into two parts: mass transfer 1, which will be taught this semester, and mass transfer 2 will be in next semester. Now, before going to this course, let's see what are the study materials. If you see the state textbook, I have written principle of mass transfer and separation processes. Sometimes this course is called separation processes alone, because this course, after studying this course, you will be able to solve the problem of separation processes. That will come slowly. Okay, and this is written by Binay K. Datta, and price is 550 rupees. This is the first. Second is mass transfer operation, written by Travel, that is an McGraw Hill publication, but you should go Indian edition. This is price is low, 890 rupees. Then another good book has come, the Kevin Narayanan and B. Lakshmi Kutti. It is price is 626. I will strongly recommend to buy all three books. At least you should buy at least first two books, and if possible these three books. Now you may think the why sir is strongly recommending. See, I was also a student like you. When my time also, I did not buy book when this course is going on. But when the semester was over, then I realized I should buy this book, because I did not get many things which we might get if I would buy this book that time. Now if you come to my eye, all the books are with me, and I did the mistake. I don't want you should do the mistakes. That's why I'm telling you should buy the book. There is a value. Now all this book you will get from Amazon, and there are some other books also. Let's see what are the other books in this thing. If you see if you write the mass transfer operation, okay, this type in Amazon, okay, I'm not. Now if you see the Trebal, that is very good, 4.1, that is very good books. This is 890, but 22% discount. Now it is 693, and this is the Indian edition, but don't go this one. This is international edition. That price is very high, 2700. Okay, then this book I don't know much, and why put it, this is book that the BK Datta separation processes, must buy this book. And that is another book. This is a very good book. And why I am telling you that you should buy multiple books, but then if you just solve the worked example, your knowledge will be enhanced, because different authors have different approach, and it will help you. And these are the thing. And Kiran D. Patil, there is another mass transfer 1 book. This is also very good. Other than this thing, if you give the separation processes, then the thing will come. This book, this is very good book, Gain Kaplis, transfer processes and separation processes. This is also a very good book. Then you know this. And another book is this Coulson Richardson by Richardson, fifth volume, volume 2, fifth edition. So this is there is number of edition, and another high level book is Cedar, Henley and Cedar. So these are the books, 6, 7, 8 books are very good books are available. So if you want to learn this course and if you want to do some good exercise problems, workout problems, you can consult on this book. Okay. Now this is the standard course evaluation. End sem is 50%, mid sem is 30%, and internal assessment. And generally for the internal assessment, what I do, I like to take quiz, 2 quizzes and attendance. But you understand this thing, because of this COVID pandemic situation, this evaluation may change. Already you have noticed in your previous semester it has changed. So according whatever the will be situation, accordingly we evaluate the course. Now if you see the course structure, so we have to study the 6 chapters in each semester. In mass transfer 1, we have introduction and motivation, means what is mass transfer, what is separation processes, okay. And second thing is why should we study this course, what is need of this course as a chemical engineer. So generally I will try to convince you that what is the need of this course. Then thing will come, the second chapter will be molecular diffusion, and third chapter will be convective mass transfer and mass transfer coefficients. Actually, transport processes, there are 3 transport processes. Already you have studied 2, you know unknowingly. One is heat transport, you have studied the heat transport. One is momentum transport, you have studied the fluid dynamics. Third is mass transfer, and this thing you will study. And I am just giving one example, say just in layman language, what is molecular diffusion and what is convective mass transfer. Let's take, we kept one perfume container in open condition at the corner of the classroom, and let's assume that all fans are closed and all windows and doors are closed. Then what will happen? Then that perfume molecules will diffuse slowly. Who will be nearer to this perfume bottle, he will get the first smell, and who will be the last student, he will get the smell, but it will take a long time. It may take 10 minutes. And this phenomena is molecular diffusion. Why? Because our medium is stagnant. There is no movement of medium. Now perfume molecules are diffusing through the stagnant media, and slowly it is spreading out throughout the room. But if you allow 3-4 hours, then it will be uniformly distributed. But that is when the diffusion process will take place in a stagnant media, then it is the molecular diffusion. So molecules are responsible. Okay, this is the inherent property of this perfume molecules. Okay, now let's take, instead of doing the same thing, I kept the perfume bottle at the corner, and then I switch on all the fans. Then what will happen? So then medium is not stagnant. So there is a movement of the medium. That means we are applying the external force to for the movement of this media, and because of that, the spreading diffusion of these perfume molecules will be very fast, and maybe within 2 minutes that uniformly it will be distributed. So the second phenomena is called the convective mass transfer. Already it is very much similar to your convective heat transfer. Okay, very much similar to your convective heat transfer, very much similar. Okay, and there is convective heat transfer and heat transfer coefficient. In this case, convective mass transfer and mass transfer coefficients. That's all. So molecular diffusion in stagnant media, convective mass transfer and mass transfer in a moving media through external agents. Okay. Now, fourth thing chapter we will discuss, so that is the interface mass transfer. Now, what is interface? Let's try to understand with a very simple example. You know the natural gas, CNG, compressed natural gas. Now, what is the composition? Generally, its composition is methane. But when it will come from the well, generally it is mixture of methane, carbon dioxide and H2S. And therefore, you have to remove H2S and carbon dioxide before sending to a CNG station. Okay. So methane, carbon dioxide and H2S, three are gaseous components. Now what people do, there is one chemical, ethanolamine. So if you pass this gas mixture in a liquid, okay, ethanolamine liquid, then what will happen? Ethanolamine will absorb the carbon dioxide and H2S and CO2, and therefore only methane will come. So that's why we are separating the H2S and carbon dioxide from the mixture of carbon dioxide, H2S, methane. And here if you see, there are two phases, one is gas phase and another is liquid phase. Gas phase what? That is the mixture, that is gas phase, and ethanol is liquid. So when you pass through, there is an interface between gas and liquid. There is a direct contact. But if you see in heat transfer, generally heat transfer, there is hot fluid and cold fluid, but there was no direct contact. There was one metal boundary. If you see the cell and tube, one is from tube side and another is from cell. So there is no direct mixing was there in case of heat transfer. But in case of mass transfer, there will be a direct contact. But heat transfer, there won't be direct contact. Okay. So this is the interface mass transfer. So that means carbon dioxide and methane, carbon dioxide and H2S, okay, that mass transfer is going on from gas phase to liquid phase, and there is an interface between two phases. Okay, so that is very important. We will look this chapter in very detail. Actually, and these four chapters are very important. These are the very basics of the mass transfer. And once if you will go these four chapters little bit slow mode, and more will try to convince you so that you will understand better. Okay. Thereafter, we will study the fifth, that is gas liquid contacting. Gas liquid, you can understand if you want to remove that carbon dioxide and H2S from the mixture of carbon dioxide, H2S and methane, so you need a vessel. Okay, so then which separation equipment is very good. Okay, and generally in this chapter we will study two things. One is packed bed and another is tray column. Okay, packed bed and most probably you have studied in fluid dynamics. Tray column generally, in distillation it is required, distillation of petroleum crudes. Okay, so and that will come later, and then we'll study slowly that the sixth chapter, gas absorption and steeping. Gas absorption and steeping is, I already have given the example. Okay, that removal of H2S and carbon dioxide from the mixture of carbon dioxide, methane and H2S. There are so many other examples. When we come to this chapter, we'll discuss many more examples details. This will be for this semester. For next semester, they will start with the distillation. Okay, distillation. What is distillation? Generally, we want to separate, okay, through liquid vapor mixture. Vapor liquid equilibrium you have studied, okay, in thermodynamics too. There is a that vapor liquid equilibrium data, all these things. So how, with this concept, how will you separate the molecules? Generally examples are for the distillation is crude fractionation. That we are importing crude from the, let's take a Middle East country, then what we are getting. We are getting LPG, we are getting naphtha, we are getting kerosene, diesel, lube oils, different kinds of, then peace between it. But so that there is a separation process. We are separating all these things, and distillation, through distillation, this is the process we do this. Then we'll study the liquid extraction. Okay, liquid extraction, what? Let's take, the penicillin. Okay, penicillin is an antibiotic. Okay, now it is penicillin, generally it is a fermented product. There is an organism, Penicillium notatum, and from this organism we get this penicillin, and it will be in liquid phase. So penicillin will be there with water. Now we have to remove this, separate these two. Once we have to remove water from the penicillin, then we will get the pure penicillin. So that to this separation generally used is done through this through liquid extraction. In this case, there is another chemical, butyl acetate. So butyl acetate is also liquid, and penicillin water mixture also liquid. Then mix them. Once we will mix them, then penicillin will come from water phase to this butyl acetate. Because water phase, another is organic phase. So penicillin will move from water phase to butyl acetate, and followed by crystallization. You can separate this thing. So this is the liquid extraction. Then solid liquid extraction. No, girls should love the gold, or you should know how this is coming, because gold is coming from the ore, and this is solid. Now, do you know which chemicals are used to extract the gold from gold ore? Sodium cyanide. Understand? Cyanide, if you take one drop is more than sufficient to kill a life. So this is the only chemical, okay, sodium cyanide, people are using to extract the gold from gold ore. So gold ore is solid and sodium cyanide is liquid, so solid liquid extraction. So gold is coming from this ore solid to this liquid phase. Okay. Another is the Vedanta is coming to our campus, and that their product is copper. How they are extracting the copper? That is also coming from the ore. Okay, so that is solid, and if you use sulfuric acid, so then copper will move from that O to sulfuric acid. So this the thing is happening. Okay, then we'll study that humidification and water cooling. Water cooling means, you understand that if you just generally, if you see any power plant, okay, what is the mechanism to generate the power plant? They have a boiler, either coal or in Paladena, that is natural gas. With this heat, okay, they burn the coal, or there is a furnace is there, and they generate water to high pressure steam. Okay, water to high pressure steam they generate. Then this steam is used to rotate the turbine, and then electrical part is attached to this turbine. This that rotating, that mechanical energy is converting into electrical energy, and that we are getting the electricity. But when this rotation is going on, okay, through turbine, then that high pressure steam will become low pressure steam, then it becomes the hot water. Okay, now generally in power plant they use the not on normal water or tap water or tube well water, that is deionized water. The cost of this 1 liter of deionized water, that is around 200 rupees. So they cannot throw this, they need to use, but they cannot use this hot water again to the boiler, because there will be a cavitation of pump. So they need to cool. So hot water is coming as, let's say, 70 degrees centigrade. They need to cool it to 30 degree or 35 degree. Then they can run. So how this cooling is? There is a cooling tower. If you see any power plant, there is a cooling tower is there. Okay. So this is the thing we'll discuss in this chapter. Then drying. Okay, drying of wet solid. Okay. So it is very important. If you see if you see that what dry milk we are getting, there is a drying process. Particular. Let's take, that urea is a fertilizer, and that is small granules white. How it is, but when that urea will coming from the record, that is slurry type of thing. Then there is a drying procedure. Okay, particular that procedure. Then drying of urea. Then another fertilizer is diammonium phosphate. When that is also coming now from the reactor, it is also slurry type of thing. Then but marketed product, it is small granules dry. So there is a drying procedure. Even apart from this, if you see that very simple drying of soap, drying of foods, fruits, all these things, all are, if you see, take the example of biscuits. If you see biscuits, the drying is optimum. If you see no batches, if you dry hard, then taste will go, dry low, it will be waste. So this thing is very important. That thing we'll discuss in drying of wet solid. And last thing we'll discuss that adsorption. Okay, what is absorption? Adsorption actually gas solid. Okay, let's take, there is some small water vapor, I want to remove it. So what I do, I put the silica gel. So silica gel has a property to remove this water. Okay, so this type of more examples we will study in our this course. Okay, so it is understandable, no? So what will be our strategy to understand these courses? So I am telling again, through mass transfer we can separate the molecules. And in general, in any chemical industry, when from the reactor the molecules will come, not a single product, it will be multiple products. Okay, and you need to separate them as per market demand. Okay, And mass transfer will tell you, mass transfer, this course will give you the knowledge how will you separate this one. Okay, I told crude from crude petroleum. If you have you seen this thing, this is a thick slurry type of thing, crude. This is because it is coming from the ore, so many sands, all these things are there. But if you see, finally we are getting the product, what? LPG, petrol. Is there any some impurities? Then kerosene, diesel, lube oils, so these things, how this is happening, what are the equipments we can use so that we can separate this thing equipment, that we are going to learn in this mass transfer. And there are total 12 chapters. Okay, in first mass transfer 1 we will study the 6 chapters, and if you get some time we'll study little bit of some whatever we get distillation, and in mass transfer the remaining part. Okay, for for today let's finish this thing. Okay, so in next semester, next lecture will come in more elaborate way, that is the introduction and motivation. Thank you for your attention. Stay safe and help the people how they can stay in safe. Okay, bye.